I'm going to do a continued fraction, the continued fraction of, let's see if this thing can write for me. There we go. 395 over 459. Now, the way to do this is by doing an Euclidean algorithm. So you start with 459, and it equals, you can see that it's 395. And then, of course, 459 minus 395 is 59 plus 5, which is 64. Okay. So then now we take 395 and we divide it by 64 with a remainder. 395 divided by 64 is really, I think it's 6. Let's try 6. So it's 360, 24. That's 384. And 395 minus 384 is 11. Okay, so now that we have that, we're down to 64 is equal to 5 times 55 plus 9. And then 55 is equal to 6, right? Oh, I see, I have made this mistake before. There we go. That's what happens when we don't pay attention. Let's erase all this and start over. Because where we were was with 64 is equal to, this is a common mistake that I make of putting in the product in here. Typical mistake that one would make in an exam. I was like, there's no way that that's right. Right? So then 9, this gets easier. 4 times 2 plus 1. And then 2 is equal to 2 times 1. Right? So then now, to obtain our fraction, we started with 395 over 459. So I'm going to rewrite these again. But now, we're going to obtain our fraction, our continued fraction. All right. So the first term is going to be 0, your A0 term. That we know. And then the next term comes from taking 459 is equal to 1 times 395 plus 64 and dividing it by 395. Okay, and from that we get that it equals 1 plus 64 over 395. And this is our A1 right here. So we put it in here. Okay, let's keep going. Then the next equation was 395 is equal to 6 times 64 plus 11. So now we divide this equation by 64. And this equals 6 plus 11 over 64. This is our A2. Go up here, write it in. Okay. I think I'm going to need to scoot over a little. So we've got our A1 and our A2. then we do the next equation. Again, I'm just retracing back all these equations that I did up here, right? That's all I'm really doing in here, right? So we're going to go through all these equations and divide by this number. And we're going to get all of the a sub i's for our continued fraction. All right, so the next equation in the sequence was 64 is equal to 5 times 11 plus 9, which we divide by 11. And this equals 5 plus 9 over 11. And this is our a sub 3 right here. So it's 5. Go up here and write it out, 5. This is a sub 3. Okay, the next equation is 11 is equal to 1 times 9 plus 2. Divide that by 9. And this is 1 plus 2 over 9, and this is our a sub 4. So a sub 4 is equal to 1. Okay. Then for a sub 5, we have 9 is equal to 4 times 2 plus 1 divided by 2, and this equals 4 plus 1 half, and this is a5 right here, 4. Move over so I can see it better this way. Yeah, okay, so we're at the edge, a5. And then we've got one last equation to do. Okay, let's go up here and use this space right here. The last equation that we have is 9, right? Was it 9? I think. We did 64, we did 11, we did 9. Now we gotta do 2. Yeah, that's right. Okay, so actually I can scoot it over right here because 2 was equal to 2 times 1 divided by 2, divided by 1, and this is your a6. And I keep going back and forth. So that is our equation. I'm going to write it clean. Okay, I'm going to start a new board. Okay, and then actually, yeah, here we are. So we're just going to use this is the first time that I'm using this software, so it's called Krita. I'll probably put a link for it if you folks want to use it. It's really good. It's free on the internet. And okay, so let's summarize what we did. This is 395 over 459. Okay, and of course you can see that the first term, your a0, is 0 because 395 mod 459 is 0. All right, so then just to recap the steps, we had 459 over 395 is equal to 1 plus 64 over 395. And this is what gave us this 1. Then the next one we had was 395 divided by 64 is equal to 6 plus 11 over 64. And that gave us our 6 right here. And of course, just to remind you, because I did keep the original file of all the work, what we did was just do an Euclidean algorithm. This is almost like if somebody asked you in an exam to do the least common denominator, the greatest common denominator. I keep using least when I should say greatest common denominator of these two. And of course, the answer was 1. They're relatively prime. And so you would have done all the steps for the Euclidean algorithm. And then from those, you just go through and you divide until you get these numbers. And actually, you can read them off. I mean, you can read them off right here. So if I had not done any of that, I could have just told you, just do this right here. These are your A's. But I'm doing it slow and easy just so you see how to obtain all the numbers. And there's a 6 right here. So yeah, this is how you get all of them. Yeah. So recapping up here, I'm just writing out the fractions as you would do them after you go through all the steps in your Euclidean algorithm. 64 over 11 is 5 plus 9 over 11. Then 11 over 9 is equal to 1 plus 2 over 9. And then 9 divided by 2 is equal to 4 plus 1/2. And then 2 over 1 is just equal to 2. And so sure enough, these are our A's for the continued fraction right here. They're right here. So it's 165,142. And let me see if I have any space left over in this file. Got a little space right here and a little space at the bottom. So let's use this space right here in the middle. Yeah. So really, how you write this continued fraction is like this. Let me see if I can fit it in one screen. 6, 5, 1, 4, 1/2. This would give you 9 over 2. This would give you 1 plus 2 over 9. This will give you 5 plus 9 over 11. And then from this one, you're going to get your 6 plus 11 over 64. And then from this one, you're going to get 1 plus 64 over 395. Then when you flip this, you get your final result, which is that.